Today we're going to be looking at matter. What is matter? Why, everything's the matter. This is looking at the physics of literally everything around us. So, here are the key concepts that we will cover during this presentation. All matter is made of atoms. Atoms are small. Atoms are recycled. We're going to talk about how we know that atoms exist and what they look like. We're going to talk about how atoms interact in order to create the matter around us. We're also going to talk about the fact that matter comes in different states. There are 5 as a matter of fact, and that the kinetic energy of atoms determine the state. First of all matter is made up of atoms. If we were to take this giant rock and continue to break it down until we reached the smallest unbreakable, because that's what an atom means, is unbreakable, we would get 2 atoms. Atoms are incredibly small. They are so small, it's really hard to imagine it. If you were to go out to the beach and you were to take a handful of sand grains, and if you were to break it down till you were looking at just one single grain of sand, there are more atoms in that grain of sand than there are grains of sand on the beach. Let me give it to you in a different way. If you were to take this water bottle, and if you were to take a look at the atoms that are inside this water bottle, if you were to blow them up just big enough so that they were the size of the grains of sand, the earth itself would be covered 50 feet deep all the way around in sand, just from the number of atoms that are in that water bottle. Atoms are small. Not only are atoms small, but they're also mostly empty space. And we'll talk a little bit more about that in a minute. Now, as you have probably learned in earlier classes, matter is not created or destroyed. All matter began with the Big Bang. All matter was mostly hydrogen and helium, which are very, very simple atoms, with hydrogen having 1 proton and 1 electron, and helium having 2 protons, 2 neutrons, and 2 electrons. So if all matter started out as primarily hydrogen and helium, where did all of the bigger atoms come from? Well, they came from supernova. Supernova is one of the final stages of a giant star's life, and matter collapses in on itself and then is expelled throughout the universe in a huge super explosion. Now, when this explosion happens, these small particles end up collapsing together at such a high force that they stick together, making bigger atoms. So that the matter that we see today was once part of a supernova. Now take a look at your hand. This means that you are really made out of stardust. Everything that we see around us is made from recycled stardust. So the atoms that you are breathing today have been recycled. They've been recycled since the beginning of time and will continue to be recycled. So how do we understand an atom? The term was first coined by the ancient Greek Democritus, who said that all matter could be broken down to its smallest uncuttable point. Now, the term atom itself comes from the Greek word atmos, which means uncuttable or unbreakable. This idea did not catch on very well, and so it was many, many hundreds of years later when Dalton created the billiard ball model. The billiard ball model said that atoms were these circular balls that came in different shapes, different sizes depending upon the atom. But they were all generally a positively charged object. Thomson, almost 100 years later, discovered negatively charged particles and developed a different understanding of what the atom was. He said that an atom was really primarily positively charged matter, kind of like a matrix, and embedded into this matrix there were random negative particles, and kind of like raisins in a raisin pudding. Rutherford looked at this model and was actually testing it using his famous gold foil experiment when he discovered that rather than the raisin pudding model, that an atom was actually a very small, very dense positive center surrounded by negatively charged particles. A year later, Niels Bohr modified this understanding and said that not only did we have our positive charge center, but that the negative charges didn't just exist, but they were embedded in orbitals where there was a certain number of electrons that could exist. Now, this model ended up being disproved. However, it is still one of the best models we have to help us understand some of the behavior we note of atoms. Heisenberg changed Bohr's model and identified that while, yes, we have the small, dense, positively charged center, that there was no way to lock in exactly where an electron was, per se, but that instead we had probabilities. There was a higher probability that an electron might be found in this area, and less of a probability that it would be found in one of these outer areas. So it became more of an electron cloud or an electron smear model. Now, in 1932, Chadwick discovered the neutron. And the neutron is important because it helps to explain what we find in our nucleus, which is that we have these positively charged particles. Well, naturally, positively charged particles wish to repel each other. So the neutrons, or the neutrally charged, could possibly act as like a glue, but they also explained the different masses or isotopes that we find in different atoms. Now, since then, scientists have been exploring subatomic particles. How do we know what they look like? Well, to start off with, we first observed their behavior. If you were to take a drop of a drop of food coloring and drop it into a glass of water, you would notice very quickly that instead of dropping straight down to the bottom or floating at the top, that the dye would actually start moving in an interesting pattern, a very random pattern, through the liquid. Now, this is called Brownian motion, and it was our first proof that atoms actually existed, because what is happening is that those dye particles are actually being bounced around by the atoms by the molecules in the water. Now, it wasn't until Einstein who gave us some theories and calculations that we were actually able to map and better understand this motion. And now today, with tunneling electron microscopes, here are some examples of images created by tunneling electron microscopes. Now, it's important to note that atoms are so small we can never actually see them because they are actually smaller than a light wave. So what we have in an electron tunneling microscope is the electrons come down and they hit the surface, and they tell the computer where we have high and low parts. And by understanding and interpreting those high and low parts, we create images to help us see what atoms look like. So what are the parts of an atom? There are three primary parts. We have our proton, which is positively charged. We have our neutron, which is negatively charged, and we have our electron, which is negatively charged. Now, these are not proportional. If these were proportional, first of all, if the proton was proportional, you could not see the electron on here. If this electron was proportional, these protons and neutrons would be larger than an elephant. So The protons and neutrons are huge compared to the electron. However, they are tightly bound into a nucleus. So protons and neutrons are nucleons. They live in the nucleus. The nucleus exists in the center of our atom. Around it, in what we call our electron smear or cloud, we have the probability of where our electrons will live. Now remember, I told you it was mostly empty space. If we were to take an atom with one proton in the middle, just a hydrogen atom, and one electron, and we were to blow it up to the point where the nucleus, our one proton, was the size of a penny, the radius of our atom would be larger than that of the moon, and you still could not see the electrons. Now, we have about 109 naturally occurring types of atoms. So what makes up all of the matter around us? Well, it's how those atoms are put together. I like to think of these particular 109 elements as being like different kinds of Legos. With a handful of Legos, you can make a huge number of things depending on how you put them together. Well, our universe seems to have given us 109 naturally occurring ones, and from these naturally occurring building blocks, all of the things that we see around us are formed. Because this is done through interactions, well, we call them bonding. The atoms bond, and they bond together in several different ways. There's covalent, and there's ionic bonding, as well as some others. But what I want you to know is that the atoms form elements. These are literally just, it's like taking just one kind of Lego and putting them all together. It's a pure substance. They also form molecules and form compounds when we mix up different kinds of atoms and create different things. Now, matter can be found in different states. You've learned about this since early elementary school, so I won't spend too much time on it. But these different states have different properties. Now, here is something that might be new information. These properties are determined by the kinetic energy. Now remember, kinetic energy is the energy of movement. So as our atoms are moving, it changes the properties of matter. First of all, let's take a look at solids. Solids have a definite volume and a definite shape. If I put one into a cup, it will have a certain volume and it will maintain its shape. They are solid and rigid and cannot be compressed easily. That means if I put pressure down on here, or to the side, or from the bottom, I cannot compress it or make it smaller easily. Now, I can to a small degree, but it's not an easy thing to do. Solids are often crystalline in structure, meaning that the way that the atoms have formed together are uniform and structured. Adding heat energy changes it into a liquid state. This is a process of a phase change called liquefaction. We also call it melting. Now, what is happening on the atomic level? The atoms are tightly compact, bonded, but remember, each atom is still vibrating, but not with enough energy to actually break the bonds that are connecting it to the surrounding atoms and have it break free. Now, when we add heat energy, we will begin to break these bonds and allow the atoms to start shifting and moving around smoothly by and past each other. So a liquid has a definite volume, but no definite shape, and acquires the shape of its container. You've seen that happen when you pour a glass of water. The water takes the shape of the container. Liquid is sometimes compressible. It's usually more compressible than a solid, but it's only sometimes compressible. Adding heat energy changes a liquid into its gaseous state. This is called vaporization. It's also called boiling. It's also called evaporation. Now the difference between these, boiling is something that happens from the bottom, where near the heat source. Evaporation happens near the top, where the atoms are randomly being given more energy and are drawn off into the atmosphere. And vaporization occurs when all of the matter, all of the liquid is changed into a gas all at once. Now, if we remove heat energy, what we are doing is we are solidifying, another word for this is freezing, and we are causing bonds to tighten up again. Now, a gas happens when we continue to add heat energy to our liquid and continue to add heat energy until the atoms have so much energy they break completely free from each other and are bouncing around off of everything. So gases have no definite shape or volume. It will acquire the shape of the container, the whole container, top to bottom, and it will spread out to fill the entire container. A gas is not rigid, and it is easily compressed. You can see from all of the space between our atoms that we could, by putting pressure, actually compress our gas down to fill a smaller volume. Removing or adding heat energy changes, depending upon its variables, it into a plasma. A plasma exists when the atoms are moving so quickly that the electrons are stripped off and it glows. But removing heat energy changes it back into its liquid state. This is condensation. So, things to remember. All things are made out of atoms. Atoms are small, very, very small. Atoms are recycled. The behavior of atoms determines the properties of the matter, and it all depends upon kinetic energy. But there are two more states of matter that we have not really addressed: plasma and the Bose-Einstein condensate. Check out the next video to learn about those.